Next section in chapter 12 is about sector area and arc length. So by the end of this lesson, we should find the area of sectors and find arc lengths. So the area of a sector is a fraction of the circle containing the sector. To find the area of the sector whose central angle measures m degrees, we need to multiply the area of the circle by the measure of our angle divided by 360. So what we're really doing here is we're finding what fraction of our circle do we really care about. So when you're looking at an entire circle like this area would be pi r squared. But we don't want the entire circle. We only want a fraction of it. So let's say that this was like 60 degrees. That would be 1/6 of our total area. So that's what we're doing here by doing 60 divided by 360. So a sector is like a slice of pie. So find the area of each sector, give answers in terms of pi, and round it to the nearest hundredth. So they want both. So when we take a look at this, we want to know the sector HGJ. So this slice of pie right here, how much area is this? So what we would do to find the area of the entire circle is do pi r squared. And they tell us our radius is 12. So we end up with 144 pi. That would be if we ate the entire pie. But now remember, we're just eating this slice right here. And this slice is 131 degrees out of the 360 total. So we're going to multiply 144 times 131 and divide that by 360. And when you do that, you end up with 52.4, and then we have to remember to multiply that by pi. So this is in terms of pi. That was one of our answers that they wanted us to find. And then the other one is they want us to type that into our calculator and round to the nearest hundredth. So if you type in 52.4 times pi, you end up with 164.62 meters squared. This should have meters squared on it as well. So there are two answers. Now if we want to talk about a segment, that is when you have an arc and then you chop the chord off. So it's a region bounded by an arc and its chord. It's just this little section up here. So you have the area of a sector that we have the chord, and then we take out this triangle here. So our formula is find the area of the sector like we just did, find the area of the triangle, and subtract them. So let's say we have something like this. Find the area of segment LNM to the nearest hundredth. So I want just this shaded in part right here. So the first thing we're going to do is find the area of this sector, this whole piece in here. So in order to do that, remember you're going to do pi r squared and then multiply it by however many degrees we have divided by the total. So pi times our radius, which is 9, squared. And then this is 120 degrees out of the total 360. So when we type this all into our calculator, 9 squared is 81, and then 120 divided by 360 is 1/3, so we'll multiply it by 1/3. We end up with 27 pi. So this is the area of just this slice right here, everything in blue. So now we have to find the area of our triangle so that we can subtract them. So when we look at our triangle here, we don't know what we need to know. Remember, to find the area of the triangle, we need a base and a height. The two pieces of information they tell us is because both of these are radii, they're 9, and they give us the degree. This whole thing is 120 degrees. So what we're going to do is use some trig. So if this whole thing's 120, that means this right here is 60. And we got to find this length, and we got to find this length. And then we'll double it to find this total over here. So pretend that we have just this triangle here with 60, we have x, we have y, and we know this is 9. Let's find x first. That would be adjacent over hypotenuse, so we're going to take the cosine of 60. And if we throw this into our calculator, we end up with 4.5. So that's the height of our triangle. And then if we want to find y, we would end up with the opposite over hypotenuse, so that's the sine of 60. And if we put that into our calculator, we get 7.8. So that's this distance right here, 7.8. So now if we want the whole base of the triangle, we got to multiply it by 2. So that gives us 15.6 as our base. So now the area of our triangle is 1/2 our base times our height. And if you throw that into your calculator, we get 15.6 times 4.5, cut that in half, you get 35.1. So that's the area of this triangle here. So now to find the area that we really want, the shaded in region, we have to take the 27 pi and subtract 35.1. So 27 times pi is about 84.8. If we subtract 35.1, we get about 49.7 centimeters squared. So the triangle is definitely the hardest part to find. You could have used our special right triangles and come up with these things that are more exact if you wanted to. That's totally fine as well. Arc length is the distance around the circle. So if I wanted the entire distance around the circle, remember that's circumference, and circumference is 2 pi r. But since I don't want the whole thing, I want a fraction of it, we're going to multiply it by the fraction of degrees that we have, however many degrees out of the total 360. So you'll get some problems that look like this. Find the arc length, give answers in terms of pi, and rounded to the nearest hundredth. So we need to find the distance from F to G. I want to know what this measure is right here. So if I wanted the entire circle, I would find the circumference, which is 2 pi r. So 2 times pi times my radius. Or it'd be 16 pi. That would be all the way around. But I don't want all the way around. I want 134 out of 360 degrees. So because we have to give this in terms of pi, let's multiply 16 times 134 and then divide by 360. And you end up with 5.96 pi centimeters, since it's a distance. And then to the nearest hundredth, all we would have to do is multiply that by pi, and we get about 18.7 centimeters is how long that is. So basically, you have to know your circumference and your area formulas for a circle, and then we're only finding part of the circumference or part of the area for our circles. So those are your I cans. Find the area of sectors and find arc lengths. We'll do some practice in class, so make sure you write down any questions you have. Enjoy your night.